Let's understand the Earth's crust in this video. When UPSC asks anything in physical geography, they're indirectly testing whether you can visualize the Earth in layers. So in this video, we will do three things in order. First, we will lock the interior structure. Second, we will connect it to rock types and the rock cycle. Third, we will see how this creates mountains, plateaus, plains, and erosion features. Keep that flow in mind. Once that is clear, you stop memorizing and start predicting. Let's start with the Earth's interior structure, like a geological cross-section. The slide gives you a clean definition. Crust plus upper mantle together make the lithosphere. This is the rigid outermost shell. Below that, we have the lower mantle, also referred to here as the asthenosphere, described as a plastic semi-solid layer with density around 4.5 grams per cubic centimeter. Then comes the outer core. It is liquid iron, and this is where the Earth's magnetic field is generated. And the inner core is solid iron, with temperature shown as 11,000 degrees Celsius. Now the UPSC hack box is telling you what toppers do. They keep one anchor in mind. NiFe means nickel plus iron is at the center. And the rule is density increases with depth. Crust, less than mantle, less than core. Hold that, because now we zoom into the part UPSC loves to compare. So what exactly is the crust? There are two major crust types, continental and oceanic. Continental crust is linked here with Cl, silica plus alumina. Rock example given is granite. Age given is younger, around 200 million years. Oceanic crust is linked with sima, silica plus magnesium. Rock example given is basalt. Age given is older, around 3,600 million years. Now the trap alert on the slide is the real point. Do not confuse Cl with sima. Cl, continents, floats on sima, oceans. That floating idea is the exam logic. Continents sit higher because they are more buoyant compared to oceanic crust. Now that crust is clear, we need to connect crust material to the three rock families that keep recycling. So, instead of treating rocks as chapters, treat them as a cycle. There are three building blocks. Igneous rocks are called the parents, born from fire, magma. Sedimentary rocks are called the archives, born from deposition. Metamorphic rocks are the shapeshifters, born from pressure, PVT. And notice the arrows. Weathering and erosion moves rock material towards sediments. Burial, compaction, and cementation convert sediments into sedimentary rock. Heat and pressure pushes rocks into metamorphic forms. And melting can take them back into magma, creating igneous rock again. The line at the bottom is the mindset. The Earth is a recycling factory. Nothing is permanent. Every rock is in transition. Now let's break each rock type quickly, the way UPSC expects you to. So, what makes an igneous rock? Igneous rocks form when magma cools and solidifies. There are two routes. Plutonic, also called intrusive, it cools slowly, so it forms large crystals. Examples given are granite and diorite. Volcanic, also called extrusive, it cools fast, so it forms small crystals. Example given is basalt, connected here with black soil. Now a concept check that saves you from a basic mistake. Why no fossils in igneous rocks? Because the intense heat of magma destroys all organic matter. Once that is clear, we move to the archives, the rock type that actually stores fossils and layers. Now let's understand what defines sedimentary rocks. The process mentioned is lithification, meaning sediment turns to rock by pressure. Key feature: stratified and fossil-rich. Stratified means layered, and the exam hack line is important. Strata are time capsules. Layers are basically a record of changing environments over time. Now the slide classifies sedimentary rocks into three buckets. Mechanically formed, with examples sandstone and shale. Organically formed, with examples limestone and coal. Chemically formed, with example gypsum. And the trap alert is worth noting. Not all fossils are sedimentary. Many aspirants misread that as fossils can appear in igneous. That is not the point. The point is, fossils can be preserved in other contexts too. But sedimentary is still the classic fossil storehouse. Now we come to metamorphic rocks. What is metamorphism? Metamorphic rocks are distorted by heat and pressure. The agent of change is PVT, pressure, volume, temperature. The outcome is recrystallization, and the characteristics are clearly listed. No fossils, no stratification. Now the UPSC hackline is exactly how you should write it in mains. Metamorphism changes the character of the rock without melting it back into magma. That one line distinguishes metamorphism from igneous formation. Now comes the most common prelims pattern: source rock to metamorphic pairings. This table is a direct prelims minefield, so treat it like a checklist. It is called the Great Transformation List, and it says direct prelims questions often come from this table. From the igneous origin side, clay transforms into slate, granite into gneiss, mica into schist, gabbro into serpentite. From the sedimentary origin side, limestone into marble, sandstone into quartzite, shale into schist, coal into graphite or anthracite. Now the exam hack on the slide tells you a smart priority. Focus on the sedimentary to metamorphic pairs. Those are asked more frequently. And the trap alert is the key confusion. Shale can transform into both slate and schist, but through different processes. This is where toppers do one thing. They do not learn the table as a list. They learn it as pairs that can be reversed in the question. Now we shift from materials to landforms. Now that you know what the Earth is made of, let's see what the Earth builds. First type: fold mountains created by collision. The diagram shows compression forces pushing inward. Sediments in a geosyncline get folded and uplifted. Key facts are listed clearly. Mechanism: folding of sediments. Type: mountains of elevation. Wealth: rich in tin, copper, gold, petroleum. Examples: Himalayas, Alps, Andes, Rockies. And the exam hack is direct. These examples are classic fold mountains formed by compression. Now we contrast this with mountains formed not by squeezing but by cracking. Now look at the title logic: crack and cone. Block mountains form due to faulting via tension, meaning pulling apart. The diagram shows fault lines, a raised block called horst, and a rift or graben on the downthrown side. Examples given are Vosges and Black Forest. Then volcanic mountains. Cause: accumulation of lava. Examples: Mount Fuji and Mount Cotopaxi. and the diagram highlights lava layers and ash layers. The trap alert is exactly what UPSC tests in assertion-reason format. Block mountains are often created by tension, whereas fold mountains are always compression. Now we move to the next major landform, plateaus. Plateaus are called the storehouses, and that word is intentional. A plateau is a tableland, a high, flat surface. Formation cues on the slide are tectonic uplift and lava sheets. Then plateau types with examples. Tectonic. Tibetan Plateau, described as intermontane. Volcanic. Deccan Plateau, India. Dissected. Scottish Highlands. And the economic value box gives you the GS linkage. Plateaus are mineral vaults. Africa, gold, diamond. Brazil and Deccan, iron, manganese. This is a classic integration point for mains. Physical geography shapes resource geography. Now we go to the landform that feeds civilizations. Now let's talk about plains, the breadbaskets. Two types are shown. Structural plains are formed on undisturbed, horizontally bedded rocks. Examples given are the Russian platform and the Great Plains of USA. Then depositional, also called alluvial plains. They are formed by river sediments. They are described as the world's most productive farmland. Examples given are the Indo-Gangetic Plain and the Nile Delta. A good exam habit here is to separate the process in your head. Structural is about stability and horizontal bedding. Depositional is about material brought and laid down by rivers. Now we expand plains beyond rivers because wind and ice also build plains. This is Plains Part 2, Ice and Wind. On the glacial side, we have till or drift plains, also called boulder clay. On the Aeolian side, we have less. Less is defined here as fine dust from deserts. Examples given are northwest China and Pampas, Argentina. This is a neat prelims point. Less looks like soil, but it is wind-blown dust, and it is extremely fertile. Now we close with erosion landforms that appear after long wearing down. Now, not everything is built by deposition. Many things are revealed by erosion. The slide calls them sculptures of erosion. Inselberg is defined as an isolated hill remaining after erosion. Pediplain is defined as a gentle slope formed by mechanical weathering in arid areas. Then the term definition box helps you avoid mixing two similar sounding terms. Peneplain means almost a plain, linked here with humid erosion. Pediplain is arid or desert erosion. This is a classic UPSC confusion zone. Peneplain, humid. Pediplain, arid. Now we wrap the entire story in one blueprint. Let's summarize like a geologist. First, interior, core and crust. Second, materials, igneous, sedimentary, metamorphic. Third, architecture, fold mountains, plateaus, plains. And the final line ties it together. From the density of the core to the fertility of the loess plains, physical geography is a connected story. If you can explain it in this sequence, you are exam ready.